Hello there everyone. Kumusta? This is Dr. Janet JFRabut once again. Lend me your ears as I discuss to you the concept of sets. Before we will start, let us forget everything we know about numbers. Or let us forget that we know what number is. Instead of math with numbers, we will now think about math with things or objects. Okay? By the way, the objectives of our lesson for today, we have number 1, define sets. Number 2, write sets in different forms. And number 3, name the different types of sets. First, we specify a common property among things, and then we gather up all the things that we have this common property. For example, the items you wear: hat, shirt, jacket, pants, and so on. This is known as set or a set of OOTD. Or another example is type of fingers. The set includes index, middle, ring, and pinky. So it is just things grouped together with a certain property in common. Now let us define the word set. It says that set is a collection of well-defined, distinct objects. The word well-defined refers to a specific property which makes it easy to identify whether the given object belongs to the set or not. The word distinct means that the objects of a set must be all different. For example, the BS Ed Filipino students whose weight exceeds 45 kilograms represents a set. Another example, the rare ornamental plant collections of Dr. De Chavez represent a set. There is a fairly simple notation for sets. We simply list each element or member separated by comma, and then put some curly brackets around the whole thing. So here, A, B, C, and E are called the elements. So as you can see, there is no repetition among the elements. So each element in that set is distinct. And this symbol is the braces. This is the notation for the two previous examples. Notice how these examples are written. The first one has 3 dots together called ellipses, meaning there are more elements in that set. The second set has index, middle, ring, pinky, meaning it has an exact number of elements. To understand more about set, let me discuss to you the different representations of sets. How do we write sets? Number 1, statement form. In this, well-defined description of the elements of the set is given, at the same time are enclosed in curly brackets. This is an example of a statement form way of writing a set. 1. A set of football players with ages between 22 years to 30 years. So that is in statement form. It explains that this is a set of football players with ages between 22 years to 30 years. And notice that it is enclosed with 2 curly braces. And another example, a set of numbers greater than 30 and smaller than 55. Okay? The second representation of set is by roster form or tabular form. In this, elements of the set are listed within the pair of brackets and are separated by commas. Now, this is an example of a roster form or tabular form representation. As you can see, The elements are enclosed with two curly braces, and each element is separated by comma. Number 3, set builder form. In this, a rule or the formula or the statement is written within the pair of brackets so that the set is well defined. In the set builder form, all the elements of the set must possess a single property to become the member of that set. Now, this is an example of a set builder form. Let P is a set of X such that X is a counting number and greater than 12. Or it is written this way: P is equal to X such that X is a counting number and greater than 12. Or we can read this one as let P is a set of counting numbers greater than 12. Now let's have another example. Let A denote the set of even numbers between 6 and 14. It can be written in the set builder notation as A is a set of X such that X is an even number and X is greater than 6 but less than 14. Or A is a set of X such that X element of P, X is greater than 6 but less than 14, and P is an even number. Now let us try this one. Write the given set in 3 methods of representation. Given the set of integers lying between -2 and 3. So this is the restriction, the numbers between -2 and 3. So in statement form, you can write it like this. I is a set of integers lying between -2 and 3. How about in roster form? We can write it as I is equal to, or I is a set of -1, 0, 1, and 2. Why we have these elements only? Because these numbers, -1, 0, 1, and 2, are the numbers between -2 and 3. So that is the condition. And how about in set builder form? We can write it like this. A is a set of X such that X, element of I, and X is greater than -2 but less than 3. Do you understand? There are many examples in your module, so I hope that you will practice writing the 3 methods of representing your sets. Okay, so let's move on to the types of sets. The first type of set is empty set or null set. A set which does not contain any element is called an empty set, or the null set, or the void set, and it is denoted by phi. In roster form, phi is denoted by 2 braces with no element inside, or an empty set is a finite set. Since the number of elements in an empty set is finite, example 0. So we can say that empty set is a finite set. The second type of set is a singleton set. When we say singleton, it is a set which contains only one element. For example, A is a set of X such that X is neither prime nor composite. So we all know that this restriction will give us only one answer. And what is that? What is that number that is neither prime nor composite? And that is only 1. And how about the next example? B is a set of X such that X is a whole number and X is less than 1. So by that given situation, which is a whole number that is less than 1, and what is that? What do you think? Only 0. 0 is a whole number which is less than 1. That is why these conditions will give us one element only in a particular set. So that is singleton set. The third type of set is what we call the finite set. When we say finite, it is a set which contains a definite number of elements, meaning we can count the exact number of elements in a particular set. And take note, empty set is a finite set. For example, the set of all colors in the rainbow. So we can identify what are the colors found in the rainbow. So we have red, orange, yellow, green, blue, indigo, and violet. So we can identify exactly the colors of the rainbow. And another example, n is a set of x such that x is an element of natural numbers and x is less than 7. So we can identify natural numbers which are less than 7. So we have 6, 5, 4, 3, 2, 1. Okay. Another example, P is a set of 2, 3, 5, 7, 11, 13, 17 up to 97. So we can count the prime numbers which are the elements of P from 2 up to 97. The fourth type of set is what we call the infinite set. When we say infinite, it is the set whose elements cannot be listed because of so many elements, or set containing never-ending elements. So I have mentioned kanina that we can write a set using the 3 dots together, or what we call ellipses. That means the elements continue on. Okay, let's have another example. Set of all points in a plane. So if there are so many points in a plane, so better write it with ellipses. Then another one, A is a set of x such that x is an element of natural numbers and x is greater than 1. Hindi natin alam saan mag-stop yun kasi there are so many numbers, natural numbers rather, which are greater than 1. So we can say that these are examples of infinite set. The fifth type of set is what we call the equivalent sets. Two sets, A and B, are said to be equivalent if their cardinal number is the same. Example, the cardinality of A or the cardinality of set A is equal to the cardinality of set B. And this is the symbol for equivalent. For example, set A is a set of 1, 2, 3. Here, the cardinality of A is equal to 3. So when we say cardinality, it is the number of elements in a set. And set B is equal to PQR. It's a set of PQR. Here, the cardinality of B is also 3. Therefore, set A is equivalent to set B. So regardless of what are the objects inside a set, as long as that they have the same cardinality, they are said to be equivalent sets. And the last type of set is what we call the equal sets. When we say equal, two sets A and B are said to be equal if they contain the same elements. It means that every element of A is an element of B, or the other way around. For example, set A is a set of P, Q, R, and S, and set B is equal to a set of P, S, R, Q. So, as you can notice, whatever are the elements of B can be found in A and vice versa, although it only matters in the arrangement. Therefore, we can say that set A is equal to set B. And that ends our lesson for today. Hope that you understand what I discussed to you. But anyway, if you have questions, you can message me in our group chat. Thank you very much for listening.